Hello everyone, I'm Nipun and today I'll be talking about MySQL HeatWave. Basically it's an overall overview of MySQL HeatWave. MySQL HeatWave is a fully managed database service from Oracle, and in some ways when you start off, so MySQL has been optimized and designed for transaction processing, and that's how we started off with. And in some ways, if you look at it, it's similar to the offering from AWS, like Aurora or RDS, except that our flavor of MySQL is the enterprise edition of MySQL. It has many security features, and over the last few years, we have been augmenting with cloud-specific capabilities which are only available in our version of MySQL. We started off with the transaction processing capabilities, and then we added the analytic capabilities. And as Wim was mentioning earlier today, HeatWave provides a scale-out capabilities for analytic processing. So what we did was we took the MySQL, augmented it with analytic capabilities and machine learning-based automation, which we call Autopilot. Now this is some functionality which you get from services like Redshift, Google BigQuery. Then we added support for machine learning inside the database. And if you were to be running your application in AWS, you would need a combination of, say, Aurora, Redshift, SageMaker. Now recently we have added support for data lake, and what that means is if you have data in the object store in files in different file formats, CSV, Parquet, Avro, the same HeatWave cluster can process data in the object store. And finally, what we have added the capability is that you can run queries which combine data in the database and data in the object store, and hence the term lakehouse. So what we have with MySQL HeatWave is a single unified database service, fully managed, which offers transactional processing, analytics, machine learning, and processing capabilities in the object store, all with a single service. Now this is in contrast to multiple services you would need if you were to be running on AWS or GCP and such. Also note that this service is available from Oracle in OCI, in AWS, as well as Azure. Now, not only is it a single service, but it is 100% compatible with MySQL. So what that means is we have enhanced or augmented the MySQL optimizer. We have enhanced and augmented the MySQL storage engine so that when the processing is being done in HeatWave, it is completely transparent to the application. So all existing tools and applications which work with MySQL, whether on-premise or in the cloud, will continue to work as is without any change. Now, what is the reason people use these variety of different services? Typically what happens is if you look at a customer like running Aurora, they have Aurora for transactional processing and they use Redshift for analytics. And the reason is they like the capabilities of MySQL for a variety of reasons, but they want the performance of Redshift for analytics. What we are talking about is a single database which is doing all of these things: analytics, machine learning, transaction processing. So sure, it's a single database, but the question is, how does it compare with Redshift, which does say only one thing, which is analytics, or how does it compare with Snowflake? So we have a single database which is offering capabilities for transaction processing, analytics, machine learning, processing data in the object store. It is fully compatible with MySQL syntax. But what is also very interesting is that when you compare with the performance and the cost of specialized databases like Redshift, like Snowflake, like BigQuery, like Azure Synapse, it's significantly better. Now the mileage you're going to get varies by the workload, but on say this, for this example, which is 30 terabyte TPCH workload, HeatWave is about 5 times faster at 1/6 the cost. So single database does multiple things, and if you compare with a specialized database like Snowflake, it is 30 times better price performance. It is 18 times better price performance than Redshift. Right? So it's extremely compelling. And the question is, how did we do this? Because why are other vendors not able to do it? And there are really 3 things from an architecture standpoint which give us this capability. The first thing is HeatWave has been designed from the ground up for massive scalability. As Wim said earlier today, most of the research for this was done in Oracle Labs, and this came out of Oracle Labs. So we spent almost a decade of research. What we have is a system which reads data from the MySQL database into the memory based on the queries, right? And it partitions the data. So the partitioning of the data in memory is done based on the workload. The second thing is when you have these different partitions and you have various operators like joins, group bys, scans, we have invented new algorithms to process these massive number of partitions at near memory bandwidth, or in some cases at near network bandwidth. So we create these partitions, massive number of partitions, in a manner which is workload aware, and then we process these partitions at near memory bandwidth. That's why the system scales very well for queries. The second aspect of HeatWave is that it has been optimized for commodity cloud infrastructure. By that what I mean is we use the least expensive compute. We use the least expensive storage. So for instance, our storage for HeatWave is in the object store. And the reason is because we are able to read data from the object store in parallel at very high bandwidth and at a very low cost. So we don't use locally attached SSDs like some other database services do, because we're able to get very good performance at a very low cost. So HeatWave has been optimized for commodity cloud infrastructure, and it has been optimized for OCI. And when we have the offering in AWS, it has been optimized for AWS infrastructure, right, to provide very good price. So the first aspect, which I was talking about, scalability, gives the system very good performance. This aspect gives us very good price, which is why both the price as well as the performance of HeatWave is very compelling. And the third aspect is MySQL Autopilot, which is machine learning based automation. There are two advantages of machine learning based automation. First of all, it's workload aware. So what that means is when I was talking about partitioning of data in memory, this is not static partitioning. The partitioning is done based on the workload. So if your queries change, the recommended partitioning will change, or the key on which you partition the data will change. So it's workload aware partitioning. The second aspect of machine learning based automation is that it can predict the improvement the system is going to see. Now in a rule based mechanism, like many of the times the rules are static, and B, you can always make a static recommendation. Here the system makes a recommendation based on the workload, and B, it can predict what is the improvement the user is going to see so that the user can decide. Similarly, some of the other optimizations we have during the query plan, as you run more queries on the system learns from the previous queries and gets more intelligent. That's the advantage of machine learning. So HeatWave has built-in machine learning based automation for all kinds of workloads, OLTP, analytics, as well as data in the object store. A result of this is a system which is very scalable. So the graph over here is showing the scale factor for end-to-end queries on an aggregate of many queries, the TPCH workload and the TPCDS workload. And this graph goes up to 60 different servers, and you can see the scale factor is 0.9, where a scale factor of 1 would be perfect scalability. Right? So what this shows is that as you add more servers, HeatWave scales nearly linearly. And that's one of the reasons I say that HeatWave has been designed and optimized for cloud scale. When we had taken this graph, it was at 60 servers, but now we can scale HeatWave up to 512 servers. I'm not aware of any other database service which scales up to 512 servers. Right? HeatWave scales to 512 different distinct servers. Now, when you have a system which scales so well, the advantage of that is customers start with some workload, and as their workload changes, they can either add more nodes or they can reduce the number of nodes. Typically, if you look at most of the system, there is some amount of downtime required to scale up or scale down. With HeatWave, there is absolutely no downtime, and hence the term real-time elasticity. You can add any number of nodes, you can drop any number of nodes, and this can be done while the operations are running. It can be query operations, it can be DMLs, it can be DDLs. So the system is fully available for the entire duration. The second aspect is that once the elasticity operation completes, the system is completely balanced. Now contrast this with what the competition does. So in the case of Snowflake, you can't add arbitrary number of nodes. You can only go up in some increments of certain shapes. So if you need something which doesn't fit your size, either you have to go up to a level which you don't need, or you have to go down to a level which can be a little too less for you. With HeatWave, you can add or drop any arbitrary number of nodes. The second aspect is, since the system is completely balanced at the end of the operation, you don't have to do any step after the elasticity operation is complete. Whereas in the case of, say, Redshift, there is a downtime even after the elasticity is over, because you have to rebalance the nodes. With HeatWave, you get real-time elasticity with no downtime, and the system is fully balanced at the end of the operation, and there is no data movement between the nodes. One other very interesting characteristics of HeatWave is what we call the pause and resume feature, which means, and it is a case which is very common in analytics, that you have a system which is running, you may be running reports, and at the end of the day, you want to suspend or pause the cluster. You may do that because you don't want to incur charges. What HeatWave does is, when you pause the cluster, not only does it save the data, but it also saves the metadata in the autopilot statistics. So think of it, it's almost like hibernating a laptop. And when you resume, it is able to read the data back really efficiently, and also all the metadata and all the learnings from autopilot. So you actually resume from the same state you left off the previous day, or whenever you did a pause. So this pause and resume feature has been very popular with customers, because many times they just pause for a few hours and they resume, or for a couple of days, whatever the case may be. And the point to note is that we're able to resume at near constant time, because the reason is you have a cluster with multiple nodes, and all the nodes can read the data in parallel. So regardless of the size of the data, you can resume in constant time. Now, coming to the next segment, which is machine learning capabilities. So Wim talked at length about the capabilities we have in HeatWave. So just to highlight, what we offer in HeatWave is, in database machine learning, the data in the model never leave the database. We offer support for training, inference, and explanations. And one of the interesting things is that we support many more tasks than what other vendors do. So we have support for classification, regression, and we've recently introduced support for time series forecasting, unsupervised anomaly detection, and recommender systems. And in the keynote, you saw a demo which was based on the console. But if you wanted to invoke any of these mechanisms to do training or explanations, you just need to invoke a simple SQL command. So I've listed the 5 SQL commands. And the interesting thing is, regardless of the task, whether you have to do anomaly detection or you have to do classification, you need to invoke just the same command, just the same SQL command. So very simple to use. Now, for some of the cases, like classification regression, other vendors like Redshift offer similar capabilities. So we constructed a workload of about a dozen data sets, and we ran it on Redshift and on HeatWave. 2 important observations. One, in the case of HeatWave, there is absolutely no need for any tuning. There is no knobs required. You just give it the data set and you give it the task, and the system spits out a model which is optimized. In the case of Redshift, there are a lot of arguments which have to be given and parameters to tune the system. Even if you were to tune the system for Redshift and you compare with the model which is automatically generated by HeatWave, what you find is that it is 25 times more efficient or more performant to do training with HeatWave. So if the system takes 25 times less time to train with HeatWave, what that means is, as you have data which is changing, as you have transactional data which is getting updated, you can retrain your models and keep them up to date with HeatWave, which will then improve the accuracy of predictions. Right? That's a big advantage of training, being really fast. Since the training is really fast, your models can be up to date, which will then improve your accuracy at prediction time. And since this is all being done inside the database on the same cluster, there is no additional charge for HeatWave customers for running machine learning, like 0 charge. Whereas with Redshift, they make calls or invocations to SageMaker, and that's why there's an additional charge for customers of Redshift. Now, there are multiple customers who have been trying the machine learning capabilities of HeatWave, and all of them have a different perspective as to why they like it. In some cases, customers like some of the new models which we have, or the new tasks which we are supporting, like the recommender systems. In the case of AI call, they migrated their homegrown machine learning models with what has been generated by HeatWave. It was a lot easier to do it, and it is as accurate, if not more, than the homegrown models. In the case of Astute, what they liked was the simplicity, because otherwise it's often the case that the impediment to using machine learning is that it requires sophistication or it requires data scientists, whereas they found that they could just invoke SQL commands and get training done completely automatically. Now, all of these capabilities are available for data which is inside the MySQL database. And there are lots and lots of instances of MySQL, so there's a lot of room to grow. But if you look at the total volume of data, the majority of the data which is growing is actually not in a database, it's in file systems. So there's a lot of data out there in file systems which is untapped, and customers don't have a way of processing it very efficiently. Or even if they can process it, it is usually very expensive. So what we have now done is that we have extended MySQL HeatWave to process data which is in the object store. Now I want to make an important point here, that when you're processing data which is in the object store, the data remains in object store. We do not move the data from the object store to the MySQL database. The only thing which is created in the MySQL database is the metadata, right? So the user's data always stays in the object store. And what we are able to do is that we are able to reuse the HeatWave cluster, which is used for transaction processing or for analytics, for also processing data in the object store. Right? So the same cluster being used. Now, when you look at the performance of HeatWave for processing data in the object store, it is very fast. So if you look at the load time, it is significantly faster than the competition. If you look at the query time, it is significantly faster, and it is less expensive. So if you just take, let's say, comparison with Snowflake, HeatWave is about 30% less expensive, it's about 3 times fast to load, and it's about 17 times faster to query. So the question is, how do we do it? Because I showed you what we do to process data inside the database, but how is it that when we are processing data in the object store, which is what, like Redshift's whole business or Snowflake's whole claim to fame is, that they do processing of data in the object store really fast. But what I'm showing you is we can process it much faster, we can load it much faster, and we are less expensive. And this is something which we are seeing a lot of traction, and it's a service or capability which is in beta. And later today, I'll have more details on it. But this is something which I feel is going to provide customers a very good capability for processing transaction data in the MySQL database, as well as processing data which is in the object store. These capabilities I talked about are available on multiple clouds, in OCI, in AWS, and Azure. Now, one of the points about the AWS service is that when we run MySQL HeatWave on AWS, it has been optimized for AWS architecture. So for instance, we use a different shape and a different processor architecture on AWS, just because we find that the price performance we will get on AWS will be better on that architecture. So similarly, for instance, the block size we use, right? That depends upon the kind of network or the object store bandwidth we get in AWS. So HeatWave, regardless of the cloud it's running on, has been optimized for that underlying cloud provider. We have a lot of customers who, over the last couple of years, are using MySQL HeatWave. And one of the interesting things we find is that many of these customers are actually migrating off other databases or other database services, both on-premise and in the cloud. Yesterday is an example of a customer who were using Google BigQuery, and they migrated to HeatWave. There were multiple reasons. Cost is one, performance is the second one, but the third thing is being 100% compatible with SQL standards. So everything which we are doing in MySQL, it is 100% compatible with SQL standards and with MySQL. And that's a very big plus for customers who want to develop applications and have the flexibility to move across just in case they want to use a different service. Then we have Tetris. They were using AWS, and they were using multiple database services in AWS, and they have migrated and they are live on MySQL HeatWave. We have Nabati Snacks, and this is an example of a customer who was using on-premise database, SAP HANA, and they migrated their production workload to MySQL HeatWave. And another example is Entity Solmare. They were running on Teradata, and they have migrated to MySQL HeatWave. Now, in the case of Entity, it's actually very interesting. Entity had multiple databases. They had MySQL, they had Teradata, and they had SQL Server. When they migrated, not only did they migrate the data from Teradata and MySQL to MySQL HeatWave, but also the data they had in SQL Server, they migrated. And that's a big benefit to the customers, that they are able to consolidate multiple databases into one. So to summarize, MySQL HeatWave is a fully managed database service from Oracle. It's available in multiple clouds, and it offers transaction processing, analytics, and machine learning capabilities. It offers scale-out processing of data in the object store. And by scale-out, what I mean is whether you have 1 terabyte or you have half a petabyte, the system is able to scale and process load queries with very good performance. HeatWave offers very good performance and very good price performance, both for query processing as well as for machine learning. It's the only MySQL-based database service we are aware of which has machine learning-based automation. It's available in all commercial regions of OCI, and it's available in multiple clouds. So with this, I'm happy to take any questions if there are any.